Last time on DeBuggedJNR, we looked inside a computer to see all the different parts. Today, we're going to see how these parts talk together to solve simple programs. So let's remind ourselves what happens inside a computer. We have the brain of the computer, or the processor. It does mostly mathematics and logical operations, so that's what this calculator is for. The processor also will read and understand instructions that we give it. We're going to give it problems to solve. That's going to be over here in the program. So our program will be a series of steps that we want the computer to solve for us. And then it's going to do its working and it's going to store its results in the memory over here. And all these things are connected up by lots of different wires on a big piece of hardware called the motherboard. And finally, we're going to connect screens and keyboards and mice to the computer using our plugs. But we're not going to be looking at the plugs today. Memory is where we hold all the numbers we're working with at the moment. So memory is quite a lot like your brain, when you can remember things and then you can bring those things to mind later when you need them. So let's just put some numbers in this memory to get us started. I'm going to use some colours today to represent the different numbers in our memory, just so it's easier for us to find. So we're going to have a red one, and a blue one, and a green one, and maybe a yellow one later as well. Let's say that our red is 5 and our blue is 7. And our green and yellow don't have any numbers at the moment, there's a blank. This is what our memory might look like with the things we're working on and things we might do later. And now we're going to have a program. What is it we're trying to solve using this computer? So I'm going to put in some colours, so like this. So I'm going to say green is equal to red plus blue. This is just some maths, so we need to find out what the blue number is, what the red number is, and add them together, and that's what green is going to be. This is a computer instruction, and this is what programs are made out of. And what the processor is going to do is it's going to read this instruction, it's going to understand what it needs to do, and then it's going to use the calculator to solve that problem. You've probably already worked out this sum, right? But a computer doesn't do it like this. A computer reads the instruction and it finds the answer, and only one instruction at a time, right? They're very simple circuits. So let's perform this instruction using our processor. So the first thing to do is we need to find out what number this red is. So we're going to look over in our memory and we're going to find out that it's 5, and we're going to put that in our calculator, in the processor. Then we're going to look at the operation we need to perform. So in this case it's an add, so we're going to press add, and then we're going to look at the blue and say that's a 7, so we're going to add 7, and then we're going to find the answer, which is 12. And finally, our program has asked us to store this value in the green part of memory. So we're going to commit our answer 12 to memory, and we're going to write it in over here. Computers are really good at solving these individual instructions. A program is a series of instructions, one after another, that help us solve maybe a more complicated task. So let's have one more instruction that we can solve based on what we just did. We're going to say yellow is equal to green times by red. Now, that star might look peculiar to you, but when we talk to computers, the star is what we use to represent times or multiply. So this is another instruction with a different operation. So the first thing we're going to do is we're going to find out what the green value in memory is, and that was 12. We calculated that on the previous line. So we're going to put 12 in our calculator. Then we're going to say our operation is times, so that's going to be times over here. And then finally, our last value is red, which is 5. And we're going to calculate the answer, and that's 60. And this instruction wants us to set the yellow value in memory to be 60, so that's what I'm going to do now. So we've solved a problem that was first adding and then timesing. We've done that over 2 instructions in our program. We've seen how simple instructions can be used by a processor, and then the answers can be written into memory. Now actually, all computer games and big programs are actually programmed in this same way, using very simple instructions. The only difference is that computers operate very, very quickly, so they can do many of these instructions every second. So I hope that looking at this has inspired you to go off and try writing some of these programs and doing some of this maths for yourself, and before long you'll be writing computer games.